Okay, here's your plan for today. I'll try to make this video quick and speedy so you guys have a bunch of time to work. I'm going to have you check your 10.1 homework. The answers are on the next slide. We're going to do 5 10.2 examples, and then you have homework 1 through 39 odd. So hopefully you'll have time to do all of this in class today. Here are your homework answers. You can pause the video and check to make sure you did all right. You can circle any that you want to talk to me about, and I'll work them out on the board tomorrow. Same with 10.2. So I'll have these homework answers and 10.2 homework answers ready to go tomorrow so we can talk about them in class. All right, here we go. We have 3 problems to do on this page and then 2 on the other page. And this is going to have This is going to need you to remember exponent rules. So example number 1, we have 2 to the 4 minus the square root of 5 power times 2 to the 1 plus the square root of 5 power. So I want us to think, if we had 2 to the 4th times 2 to the 3rd, we know that we are adding our exponents, so we end up with 2 to the 7th. This is the same thing. Our bases are the same. So we're just adding our exponents together. So you're taking 4 minus the square root of 5, and you're adding to it 1 plus the square root of 5. When you do this, 4 plus 1 gives you 5, and then your square root of 5's cancel because one's negative and one's positive. So your exponent ends up being 5. So now we have 2 to the 5th power, which we know is 32. So the answer to that problem was 32. Again, just recognize what property you're doing with your exponents. This next one, we have 5 to the 2 square roots of 3 power, and then the whole thing is raised to the square root of 3 power. This is similar to 5 squared all to the 3rd power. In an example like this, we are multiplying our exponents, 5 to the 6th. So that's exactly what we're going to do in this example. We're going to multiply our exponents. So we have 2 square roots of 3 times the square root of 3. You multiply the numbers out front, which are 2, and then 1 is secretly outside that other one, so that's just 2. And then you multiply the numbers underneath the radical. 3 times 3 is 9. We can simplify that. The square root of 9 is 3, and then 2 times 3 is 6. So this guy ends up being 5 to the 6th power, and then if you put that in your calculator, it ends up being 15,625. And so that would be your final answer. Last but not least, we have 3 to the 2 plus the square root of 7 all over 3 to the 2 minus the square root of 7. This is similar to 3 to the 7ths all over 3 to the 4ths. In a problem like this, you all know we're subtracting our exponents. Oops, which would be 3 to the 3rd. So in this example, that's exactly what we're doing. We're subtracting our exponents. Just be careful. So we have 2 plus the square root of 7, and then I'm subtracting this entire thing. And this is where people always mess up. So I'm taking 2 minus 2, which is 0. Those just cancel each other out. But then I'm also taking the square root of 7 minus a negative square root of 7, which means I'm really adding those two guys together. 1 square root of 7 plus another square root of 7 means I have 2 square roots of 7. And that ends up being your exponent. So your final answer is 3 to the 2 square roots of 7 power. Just make sure it's really obvious what is your base and what is your exponent. Make sure your exponent looks like it's small. Okay? 2 more examples. Okay, so with these we are solving exponential equations. That's what we're doing. We're solving them. It's a terrible arrow. And so I have little steps to make that happen. So number 1 says express each side of the equation as a power of the same base. So the reason we could do all the examples we just did is because they had a base of 2, or they had a base of 5, or they both had a base of 3. With this guy, I want to get my bases the same. right now, 1 has a base of 4 and 1 has a base of a half. So I'm going to convert those to have the same base. We kind of did this yesterday. 4 and a half both have the number 2 in common, and so 4 we know is actually just 2 to the second power. And so all I did was change 4 to 2 to the second power. And then 1/2 is really just 2 to the negative 1 power. And so I just took, because remember 2 has a secret 1 right there. And then if you move him up, he becomes negative. So now I have the same base, but I'm going to go ahead and multiply my exponents together. So this side becomes 2 to the 4x. And this side becomes 2, and then I'm distributing this negative 1, so it's negative 1 plus 2x. Okay, so we did step 1. We have the same base now. Step 2 says set the exponents equal to each other and solve. So think about it. If we have 2x, or 2 to the 4x, and we say that it's equal to 2 to the negative 1 plus 2x, that means our exponents have to be equal. So we need to figure out what that exponent is. So 4x is equal to negative 1 plus 2x. If we subtract 2 x's from both sides, then we end up with 2x is equal to negative 1. If we divide both sides by 2, we learn that x is equal to negative 1/2. And that is your final answer. That's solving exponential equations. It's all about getting that same base, just like we practiced yesterday. So same issue over here. We need to make sure our bases are the same. Right now we have 5 to the 3x, and then we have 1 over 25 to the x minus 1. 25 is really easy to switch to become a 5. So this side stays 5 to the 3x, and we can rewrite 1 over 25 as 1 over 5 squared, because 25 is really just 5 squared. We still don't have the same base though, because one's a solid 5 and then one's that 1/5. So we need to flip it. So this stays 5 to the 3x, and then if I bring him up, my exponent becomes negative. And so now I finally have the same base. I'm going to multiply my exponents together. So again, I'm distributing. This is still 5, and then it's negative 2x plus 2. My bases are finally the same, so I can just set my exponents equal to each other, and we're going to solve the equation. Plus 2x plus 2x. We end up with 5x equals 2. And then when we divide both sides by 5, we learn that x is equal to 2/5. And that is your final answer. So these are kind of as hard as it gets. Just practice getting the bases the same. This whole process of getting bases the same is never going to go away. It's kind of a staple of this unit. So the better you get at it, the better this unit's going to go. Okay? Here is your homework. Page 461, numbers 1 through 39. 19 through 39 only has one no solution. So one of the problems is going to be no solution, but there's only one of them. Once you find it, you no longer need to check your answers for no solution. So those last problems, one of those answers didn't work if you plugged it back in. Okay, so keep that in mind while you're solving these, because you may end up with a no solution. So make sure you are checking your answers. That was step number 3. All right, good luck. I'll see you guys on Wednesday.